Lesson 5-1, page 195, 1 through 25. Number 1, random variable. The accompanying table lists probabilities for the corresponding number of girls in 4 births. What is the random variable? What are its possible values, and are the values numerical? So what is the random variable? X is the random variable, and it stands for number of girls. What are its possible values? That would be 0, 1, 2, 3, and 4. Are its values numerical? Yes. Number 2, discrete or continuous. Is a random variable given in the accompanying table discrete or continuous? It is discrete. You can count the number of girls, 0, 1, 2, 3, or 4, however many it is. So it is discrete. 3, probability distribution. For the accompanying table, is the sum of the values of P of X equal to 1? Well, let's check. What do we got? 0.063 plus 0.25 plus 0.375 plus 0.25 plus 0.063. Oh, no, it doesn't equal 1, but it's 1.001, which is pretty darn close. And I would imagine this 6.3 here is probably 6.25, and it's just rounded up. Okay, so it is a little off, but it's because of rounding, and that's okay. Does the table describe them? Yes. Yes. P of X equals 1.001, which is close enough. 4, I want you to do 4 on your own and then answer it on the form sheet. Okay? Number 5, 5A. What do we got? Exact weights of the next 100 babies born in the United States. So these were supposed to determine if they're discrete, continuous, or not. And A is continuous. Why is it continuous? Because it is weights, which is a measurement. So it is continuous. B, responses to the survey question, which political party do you offer? It is not. And that's because political parties are not numerical. C, number of spins of roulette wheels required to get the number of 7. That would be discrete. It may take a while, or it may not take any time at all, but you can count the number of times it takes. Exact foot lengths of humans. Again, that's a measurement, so it is continuous. And then E, shoe sizes such as 8 or 8.5 of humans, that is discrete. Okay, and if you're unsure what discrete and continuous are, go back in your notes, look it up in the index, and maybe write that down and put it on your 3x5 card. Number 6, I would like for you to do and submit on the form. Number 7, oh, now it's a party. We get to start working with these probability distributions. If a probability distribution is given, find its mean and standard deviation. If a probability distribution is not given, identify the requirements that are not satisfied. So number 7, we have 5 males with an X-linked genetic disorder had 1 child each. The random variable X is the number of children among the 5 who inherit the X-linked genetic disorder. All right, so step 1, is it numerical? Yes, it is all numerical. All right, step 2, we need to check P of X. And I'm going to save a little time here. I'm going to go and make me a spreadsheet. And I'm going to call this X. And then I'm going to go down here and I got 0, 1 through 5. And that's just because I'm pretty sure it is. And then I'm going to call this PX. Where's P? PX. And I'm going to put those probabilities in there. 0.031. If it looks kind of fuzzy, you may just want to add it up first. 0.313. 0.156, 0.0, ooh, that's supposed to be 0.31. And then, and just to be safe, I'm going to go over here and I'm going to say equals sum of PX. All right, and that adds up to 1, so we are golden. So let's see here. We have to find the mean, and the mean is the sum of X times P of X. All right, now how do we do this on the calculator? Well, let's see, we got X and we got P of X. So why don't we go over here and we'll say equals X times P of X. And that's a column reference. Now, why did that not work? Oh, P of X equals X times PX. Enter. Okay. And X is a column reference. And it, okay, it didn't do that. It didn't. Okay. See if that fixes it. Okay, that didn't fix it either. So how about equals A times B? That fixed it. All right, so that's perfect. That's perfect. So let's going to go over here and we're going to say equals. Oh, I'm going to need to first, I'm going to need to call this C. Getting real creative here. Equals sum of C. And since that worked, I'm going to go and menu, no, doc, edit, copy, and then doc, edit, paste. All right. So we're going to call this, again, we're going to get real creative. We'll call it D. Okay. So 2.5 mu equals 2.5. And now we got to figure out what the standard deviation is. And the standard deviation equals the square root of the sum of, and that's going to be X times P of X squared times, squared times, that's going to be X minus mu squared times P of X. Okay. Now, how do we do that on the calculator? And it's really not really hard. Not hard at all. Watch this. So we're going to go over here and we're going to say equals, open parentheses, A minus D squared times B. Column reference, and there we go. Yes, sir. So that's part of it. Now the next part we're going to go here, and we're going to call this E, and we're going to go here, and we're going to say equals sum of E, enter, and then we're going to say equals the square root of this one here, 1.1. So our standard deviation is 1.1. Not too bad. There we got it. Did we answer all the questions? Yes, we did. So let's try number 8. Number 8. Male color blindness. When conducting research on color blindness in males, a researcher forms random groups with 5 males in each group. The random variable X is the number of males in the group who have a form of color blindness based on data from the National Institute of Health. Okay. Well, we're going to just go ahead and let's see here. We're going to get us a new document. So we can do this. I'm going to show you again. So we got X here. And we're doing 0 to 5. And then here we have P of X, Px. And what do we got here? 0.6. 0.659, 0.287, 0.050, 0.004, 0.001, and this is 0 plus, so we're just going to put a 0 in there. Okay, now here we go again. First, find the mean. It's the sum of X times P of X. So we're going to say equals A times B. And that should do it. And that did, no problems. And let's go and check. Yep, that looks good. So now we need the sum of that. We'll call this C. And we'll say equals sum C. All right, 0.4. And so our mean is 0.4. And now we got to find our standard deviation. And it's really not all. It don't take but just a second. Let's go over here, and then we got doc, edit, copy, and then doc, 2 for edit, and 5 for paste. And that's got it in all of them. Good. We'll call this D. Now, what's the next step? We have to x minus the mean squared times p of x. So we've got equals, open parentheses, x, and that's a, minus the mean, which is d, squared, times p of x, which is b. Column reference, there we go. And then we go over here, and let's see, we were going to call that e, and then it's equals sum of e and equals the square root of that, and that's 0.6. Excellent. 0.6. Perfect. Number nine, what do we got? Pickup line. Ted is not particularly creative. He uses the pickup line. If I could rearrange the alphabet, I'd put you and I together. The random variable x is the number of women Ted approaches before encountering one who reacts positively. What's wrong with this? They're all they're all numbers, right? Well, let's add them up. What do we got here? What do we got here? 0.001 plus 0.009 plus 0.03 plus 0.06. Oh, that adds up to 0.1. So number 9 is not a probability distribution, because the sum of the probabilities is 0.1, which is not 1 as required. From the looks of it, Ted needs some work. All right, number 10, fun ways to flirt. In a Microsoft Instant Messaging survey, respondents were asked to choose the most fun way to flirt. I would like for you to answer this one on the form that I sent. Number 11, fun ways to flirt. A sociologist randomly selects single adults for different groups of 3. And the random variable x is a number in the group who say that the most fun way to flirt is in person. So is that a probability distribution? They're all numerical. Good. Let's add them up. 0.091 plus 0.334 plus 0.408 plus 0.166, 0.999. So yes, it is. Okay, that's not off by much. Well, let's go back over here. And this is the really nice thing about these right here. We've got fun way, we go down to 3. So we're going to go down here to 4, and we're going to I'm going to go doc, edit, and delete. Okay, let's see what that did to everything. All right, well, let's see here. 0, 1, 2, and 3. And then we got to change some of these, right? We got 0.091. And then we got 0.334, 0.408, 0.166. Okay. And then we're, ooh. So remember this one here is going to be equals A times B. There we go. Now, our mean is 1.648. Mean is 1.648. And now we need our standard deviation. And let's see if it stayed there. It did not. Okay, so what was this here? Equals, open parentheses, A minus D, close parentheses, squared, times B. Column. There we go. And what do we got here? So our standard deviation is 0.86. So I'm going to just say sigma equals 0.9. My handwriting has gotten terrible over the last week. Not that it was any good before, but you know what I'm saying. Number 12, self-driving vehicle. Groups of adults are randomly selected and arranged in groups of 3. The random variable X is the number in the group who say they would feel comfortable in the self-driving vehicle. Huh. All right. 12. And if we add those up, yes it is. And we're going to go over here and we're going to go and change our probabilities. So 0, 1, 2, and 3. Excellent. So let's go over here. What do we got? 0.358, 0.439, 0.179, 0.024. Okay. And we'll look here. We have our mean is 0.86. We'll say 0.9. Our mean is 0.9. And our standard deviation, isn't technology great? 0.78, so we'll just say 0.8. 0.8. Excellent. 13. Let's get us a new sheet here. Number 13. Cell phone use. In a survey, cell phones users were asked which ear they used to hear their cell phone. There's your tax dollars. And the table is based on their responses. Okay, left, right, or no difference. So 13, well, you can't put a number on L and left, and you can't put a number on right and whatnot. So I'm going to go with not a probability distribution. Because my X values, well, there's not really, okay? Number 14, I would like for you to do on your own. Yeah. Number 14, do on your own and answer on the form, okay? And then number 15, now we're getting serious, all right? Number 15. In exercise 15 through 20, refer to the accompanying table, which describes results from a group of 8 births from 8 different sets of parents. The random variable X represents the number of girls among 8 children. So find the mean and standard deviation for the number of girls in 8 births. All right, well, first I need to know whether or not all of this adds up to, and let's see, I'm gonna start over. I'm gonna go over here and start over. I'm gonna call that X, and we got 0 to 8. I'll call this P of X, mostly out of habit, 0.004, 0.031, 0.109, 0.219, 0.273, 0.219, 0.109, 0.031, 0.004. All right. Let's go over here and equals sum of B. Oh, shoot. Let me put P of X in there. Px 0.999. Good, that works. All right, so now we'll call this C, and it equals A times B. And let's check and make sure it didn't go any further. Excellent. All right. Equals sum of C. All right. Now what is that? That is our mean. So our mean is, basically it's 4. All right. Now we need to copy that. So doc, edit, copy. Doc, edit, paste. Excellent. I'll call this E. So what are we going to do here? We're going to do X minus mu, so equals A minus D squared times P of X, which is B. Column, column, and there we go. So now we need to find the sum of that, equals oh, too many S's. SUM of E. And now we're going to equals the square root of this. And we get 1.4. Excellent. So sigma is 1.4. 16, range rule of thumb for significant events. Use the range rule of thumb to determine whether one girl in 8 births is a significantly low number of girls. So 16. What's the range rule of thumb? Okay, we're going to do mu minus 2q, which in this case is going to be 4 minus 2 times 1.4. And so let's go 4 minus 2 times 1.4. And I get 1.2, which equals 1.2 girls, because one girl is less than or equal to 1.2 girls. It is a significantly low number of girls. And I know you're thinking, well, how in the world? I'm not, let me draw a little thing here. That's not really straight, but anyway. So here is the middle, that's 4. okay? Two standard deviations would be here. And we'll say it's 1.2, okay? And one girl is less than that, so significantly low, okay? So it is a significantly low number of girls. What about number 17? 17. Range rule of thumb. Use the range rule of thumb to determine whether 6 girls into 8 births is a significantly low. Well, I guess what we need to do now is mu plus 2 sigma, and that's 4 plus 2 times 1.4. And I'm going to get 6.8. 6.8. So my other is going to be over here, and that's going to be 6.8. So the question is whether 6 girls, and 6 girls is less than 6.8, that's 6 girls, and this area here is not significant. So 6 girls and 8 births, 6 girls and 8 births is not a significantly high number. 6 girls in 8 births is not a significantly high number. Let's see here, 18. Using probabilities for significant events. Find the probability of getting exactly 7 girls in 8 births. All right, so we got X and P of X, right? 0, 1, 2, 3, 4, 5, 6, 7, 8. Well, that's a terrible 8. And then what do we got? 0.004, 0.031, 0.109, and I'm putting this so I can show you, 0.219, 0.273, 0.219, 0.109, 0.031, and 0.004. Okay, so A, find the probability of getting exact. So the probability of 7, and that's going to be right here, that is equals 0.031. B, find the probability of getting 7 or more. So the probability R is greater than or equal to 7 is 0.031 plus 0.004, which is 0.035. Okay, in other words, I added both of those. Okay. Which probability is relevant for determining whether 7 is a significantly high number of girls in 10 births? Part A or Part B? Well, it's going to be Part B. Okay, Part B. D. Is 7 a significantly high number of girls in 8 births? Why or why not? Okay. I'm going to say yes. Yes. The probability of R is greater than or equal to 7 is 0.035, which is, remember we talked about this over here and this over here, that's 0.25, and that's, well, anyway, that's 0.05. So that is less than 0.05. So the probability that R is greater than or equal to 7 is less than or equal to 0.05. So it is going to be considered significantly high. High, significantly high. Okay. 19. Using probabilities for significant events. Find the probability of getting exactly 8 girls. So the probability of 6 girls. And that's going to be 0.109. Okay? Find the probability of getting 6 or more girls. That's 0.19. That's where I got that from. So B is the probability R is greater than or equal to 6. And that's going to be 0.109 plus 0.031 plus 0.004. And I'm going to get equals 0.144. Okay, because that was 0.35, add that, that's 44. Man, all right. C, which probability is relevant for determining whether 6 is a significantly high number of girls in the 8 births? Part A or part B? I'm going to say part B. Okay, and then D, is 6 a significantly high number of births? I'm going to say no, and because the probability that R is greater than or equal to 6 is not less than 0.05, is not less than, okay? Is not less than 0.05, okay? So it does not. 20, using probabilities for significant events. Find the probability of getting exactly 1 girl in 8 births. So 20. 20A. Probability of 1 is 0.031. Find the probability that R is less than or equal to 1. That's going to be 0.004 plus 0.031, which is 0.035. And again, that's B. And then C, part B. Part B is, and then D is 1 a significantly no? Yes. Yes. The probability that R is less than or equal to 1 is less than or equal to 0.05, because 0.035 is less than or equal to 0.05. Here, it did not work because this was 0.144, which is not less than 0.05. Okay? We good? All right, so I'd like for y'all to do 21 through 25 on your own and to answer them on the form, please. I might give you a break and not have you do 25. All right. Thank you very much. Y'all have a wonderful day and enjoy.